Hello, class. Today I will be explaining the phases of an action potential and how neurons communicate. This process is essential for every move we make and every thought we have, even the awkward ones. Let's begin with a neuron at rest. So, when a neuron is not sending a signal, it maintains something called the resting membrane potential, which is typically around negative 70 millivolts. It's slightly negative inside because the sodium-potassium pumps constantly push 3 sodium ions out and brings 2 potassium ions in. This pump works nonstop. Honestly, probably harder than most of us during finals week. Next, the signals from other neurons arrive at the receptive segment, the dendrites and the soma. Chemical messengers like acetylcholine bind to the receptors and generate postsynaptic potentials, and these can either be excitatory or inhibitory. Excitatory makes the inside less negative and increases the chance that the neuron fires. Inhibitory makes the inside more negative and it tells the neuron to relax. These are called graded potentials because their strength can vary, kind of like how angry someone gets depending on how hungry they are. If enough excitatory inputs add up and the membrane reaches a number of negative 55 millivolts, the neuron hits something called threshold. And here at the initial segment, the neuron follows the all or none law. The all or none law says that either it fires completely or it doesn't fire at all. So there is no almost. Just how you don't do mixed signals with your situationship, neurons don't do mixed signals either. And this is the beginning of the action potential. The voltage-gated sodium channels open, sodium rushes into the cell, and the inside rapidly becomes positive, up to about plus 30 millivolts. This sudden flip in charge is called depolarization. It's like the neuron changes mind very quickly. And once the peak is reached, the sodium channels close and the potassium channels open. Potassium ions exit the cell and it brings the voltage back down. I like to think of repolarization as negative Nancy because this phase restores the neuron's negativity and overall attitude. Sometimes potassium channels stay open a little bit too long because they're just kind of dramatic like that. This causes the membrane to become more negative than the resting level. This is called hyperpolarization, where the neuron briefly overshoots the target. During these two recovery phases, we enter two important limits. The absolute refractory period, where the neuron cannot fire another action potential no matter what, and the relative refractory period, where the neuron can fire another action potential, but only with a very strong stimulus. Think of it as do not disturb, followed by you better have a good reason to disturb me. The action potential then travels down the axon, the conductive segment. There are two types of conduction, continuous and saltatory. Continuous conduction occurs in unmyelinated nerve fibers, and these are slower. The action potential has to travel along the whole length of the axon, while saltatory conduction occurs in myelinated nerve fibers, where instead of going along the whole length of the axon, the signal jumps between nodes of Ranvier rapidly. And this is much faster, kind of like skipping the line at Six Flags. I like to think of the S in saltatory like the S in Six Flags. You see what I did there? And finally, the signal reaches the transmissive segment, the axon terminals. Here, the voltage-gated calcium channels open, calcium enters and triggers vesicles to release neurotransmitters such as acetylcholine into the synaptic cleft. The signal then moves on, kind of like your ex moving on, to the next neuron, muscle, or gland, and communication is complete. Neurons are excellent at networking. But when they aren't networking the best, a disorder like multiple sclerosis can occur. Multiple sclerosis damages the myelin sheath, slowing or even stopping action potential conduction, and this can result in muscle weakness, numbness, and impaired coordination. This shows just how essential proper conduction is for movement and bodily function. And to wrap it up, action potentials are the electrical language of the nervous system. They allow neurons to send quick, precise messages using changes in ion flow, membrane potential, and neurotransmitter release. Without them, we couldn't think, move, speak, or even blink. Remember that even though neurons might be small, they keep the entire body running, one action potential at a time. Thank you for watching!